The question we are solving now belongs to test series 3. It is of network theory subject. In specific, it belongs to Laplace transforms or sinusoidal steady state analysis. As per the question, there is a voltage source V of S which is supplying power to a circuit which is operated at a complex frequency of S is equal to j omega radians per second, and the circuit which is supplied power from V of S has two parallel branches. One parallel branch contains a 1 ohm resistor and 1 farad capacitor, and another parallel branch contains 2 Henry inductor, 1 ohm resistance, and 1 farad capacitor. The midpoint of 1 ohm resistor and 1 farad capacitor is A, and the point connecting the 1 ohm resistor and 1 farad capacitor in the second branch is B. Please note that this circuit is operating at S is equal to j omega radians per second. It is given that phase of VABS divided by V of S is 0 degrees. So from this data we need to find the value of omega at which this condition is satisfied. So from the given circuit we see that VAB of S can be given as VA of S minus VB of S. VA of S is the potential at this point, which is the drop across this capacitor, which can be written as V of S multiplied by 1 by S divided by 1 plus 1 by S, and VB of S can be written as the drop across this capacitor, which can be obtained by voltage divider rule as V of S multiplied by 1 by S divided by 2S plus 1 by S. So from this we can write VAB of S divided by V of S as 1 divided by S plus 1 minus 1 divided by 2S square plus S plus 1. So this is the quantity VAB of S divided by V of S. Now upon substituting S is equal to j omega in above, we see that VAB of j omega divided by V of j omega is equal to 1 by 1 plus j omega minus 1 by 1 minus 2 omega square plus j omega. So it is given that phase of this quantity on the left hand side is 0 degrees. We need to find the omega satisfying this condition. From the given data, from the given options, we see that upon substituting omega equal to 1 radians per second, VAB of J1 divided by V of J1 can be simplified as 1 by 1 plus j omega minus 1 by minus 1 plus j. So this can be further simplified as minus 1, that is upon simplification, minus 1 plus j minus 1 minus j. This is equal to 1. From this we see that this is 1. The term VAB of J1 divided by V of J1 is equal to 1. It means that its imaginary part is 0, which implies that phase of this is equal to 0. From this data we can say that when omega equal to 1 radians per second, the phase of VAB of S divided by V of S is equal to 0. Hence the correct option for the given problem is A.